Okay, so here I've prepared to collect my data for a refraction lab. What I've done is traced my semicircular prism. This is made of glass. I've drawn in the normal, which is perpendicular to the air glass boundary. And I've also measured off in 10-degree intervals angles of incidences from the normal. So from each year I have 10 degrees, 20, 30, 40, 50, 60, 70. So in a second I will turn down the light and I will make sure I line up my prism the best that I can, because the more accurate I am, the more careful I am, the better my data and results come out. Okay, I know it's casting a little bit of a shadow there. There we go. It's really, really important to go through the center, because if you don't go through the center, what happens is you actually get refraction happening at both boundaries. We want the refraction only to occur at this flat edge. If we go through the center, then the emerging ray, or the refracted ray, will emerge here at an incident angle of 0, which means no refraction will occur. So I'll turn down my light so that we can still see. Okay. And I'm going to adjust this a little bit. Now there is a little bit of leakage of other light here, so I am trying to reduce that, and I come up nice and close. I put tape on the slits to hopefully reduce that, and I'm going to aim right along the 10-degree, and I try to get that pencil line right in the middle of my single ray. You can see that the ray is quite a bit wider than a pencil line. So I want to get it right in the middle. And then what I'll do is I'll take my pencil, okay, and see if I can adjust this so we can see everything at once. There we go. I have to line everything up again every time I move. Okay. So here I have it lined up in the middle, and I can see my ray coming through. Now I can see some other rays coming in there because there's a ray sneaking out through here. That's okay. We just ignore it. And I'm going to mark right in the middle, and I'm going to label that as 10 degrees. I know it's not 10-degree angle, but it's related to the incident angle of 10 degrees. So then I go ahead and move it along here to my 20-degree, and I'm going to put a little tick mark right in the middle, and from then on we know it goes up by 10 degrees, and I'll measure those angles after. Sometimes it's easier to rotate the paper than to rotate the ray box. Now, if you're looking for sources of error, okay, I can definitely see that maybe my prism gets knocked a little bit, and I'm going to keep continuing. You use however many angles your teacher is asking you to use. If you just use one, that's only doing like one trial. So that's why we want to do a couple different ones. Go, mark in the middle, and again, mark in the middle. And after I'm done all of these, I'm going to go over so you can see something about the intensity of the light. Okay, so right now maybe here's a good time to pause. You can see here, this ray of light is very bright. This light is pretty bright, but there's also a ray coming off this way. And I could measure that angle from the normal, and we would notice something. We would notice that this angle right here from the normal is the exact same as this one on this side. So your teacher can discuss with you, or you can discuss with me, what that ray is. And you can see it's dim, but as I go and keep moving along, okay, these intensities, these two here of the refracted and the reflected ray, should add up to the intensity of here. There's no way of measuring this, but you can measure it on the gizmo. And let's get there. And you'll notice the other thing that happens as your angle increases, as your angle of incidence increases, is that this ray is really changing a little bit. Okay? And that just has to do with the angle that we're at. Okay. There we go. And maybe on that last one, just to prove to you, I'll mark it. I'll mark the refracted ray. And we can see that that angle would be pretty close. So our last angle was 70 degrees. I'll turn on my light. This one was 70 degrees, meaning it corresponds with this one. And this one is here. So what I'll do now, and I'll show you a couple, and then I'll spare you from watching me do everything. It's really important, okay, that you try your best to line up the center with your little dash mark. What you're going to do is the best you can and draw on that line. And I'm going to do that for each one of these, and then I'm going to measure those angles. Okay, this is when you take your protractor. Okay, I've already measured all of these ones, right? These all down here are your incident rays. Okay, these all occurred in air. All right, now the refraction is happening right here. So these angles I am measuring in the glass. These rays do extend out into the air, but the change in direction is happening in the medium of glass. So now we're going to take our protractor and measure these angles from the normal. We always measure from the normal. And always do your best to line up a little mark there in the center. Line up your 90, because this should be 90. And the more time you take, the more accurate you'll be with your angle. Okay, so I can see here. So 10, that looks like 11. Whoops. Well, now I'm doing this one, which is okay. This one looks like 11.5 degrees. Okay, and that corresponded with the 20-degree angle of incidence. This one here looks like it is right on 6 degrees. And that corresponded with the 10-degree. Okay, and I'll continue these and measure these off. Now see here, I mean, I could be a little picky. That maybe wasn't right on my little tick line. These are things that you have to worry about when you're looking at sources of error. Okay, and so I'm just going to go ahead, connect all of these to my center and measure all these angles, and I'll take a picture of it and post it on our Google Classroom. All right. Okay, there we go. figuring out the index of refraction for a semicircular prism.